Hello everyone, my name is Gulbarshin Mukasheva, PhD, Senior Teacher of the Department Epidemiology and Biostatistics. Today I am going to present a lecture on the topic data organization. This slide shows a schematic sequence of research steps. A study usually begins with an idea, a question or problem the researcher wants to answer. Next, the researcher explores exciting knowledge on the topic to ensure the study is relevant and not a repetition of previous work. Then they define a hypothesis, expected outcome, goals, and objectives, choose a research design, and determine data collection methods. After that, the research boundaries are set, including time limits, participant selection, inclusion-exclusion criteria, and financial constraints. Once the boundaries are defined, data collection begins, followed by data analysis and conclusion. The final and crucial step is dissemination, sharing results through articles, theses, or conference presentations, since a study has no real value if its findings remain unpublished. All studies are divided into three types: naturalistic, qualitative, answers the question why; experimental, quantitative, answers the question how many; mixed type, combines both approaches. For example, a quantitative study might explore how many semi-medical students are satisfied or dissatisfied with university cafeteria meals. A qualitative study, on the other hand, would focus on why students are dissatisfied, investigating causes through interviews or discussions without relying on a predefined theory. In experimental research, the 10 stages processes step by step from the idea to the conclusion. In naturalistic research, the researcher may return to previous stages for clarification. For example, after the first interview, if students mention that food is insalted or portions are small, the researcher can conduct a follow-up interview with more specific questions like: was the food too salty? Were the portions sufficient? Thus, in qualitative research, there is no strict linear order. The researcher can modify the hypothesis, goals, tasks, or design at any stage, moving flexibly from idea to results. After learning about the different research strategies used for data collection, you might wonder, what does the researcher do with the obtained information? The researcher conducts an analysis of the collected data, but before the analysis can begin, the data must be prepared and organized properly. Usually, the main goal of any research is to obtain information about the studied objects or phenomena. The object is observation, is what or whom we study. For example, if the observation unit is a student studying throughout the entire period at a medical university, then the object of observation is all the students of that medical university. Quantitative variables divided into continuous and discrete. Continuous variables, for example, height, body weight, arterial blood pressure, can take any value on a continuous scale, including fractional parts after a decimal point. Discrete variables, for example, number of children in a family, can only be expressed as whole numbers. Qualitative characteristics are divided into nominal and ordinal. Nominal variables are those for which arithmetic operations cannot be performed and which cannot be arranged in increasing or decreasing order. For example, patient identification number, diagnosis, gender, Ordinal variables can be arranged in a logic order. For example, disease severity assessment of a patient's condition. However, it's impossible to express them numerically. We cannot determine how much or how many times one state is better or worse than another. Ordinal variables are often coded with numbers, but unlike quantitative data, arithmetic operations cannot be performed on them. Variables that can take only one of two opposing categories, for example, male and females, gender, presence and absence of disease, are called dichotomous or binary variables. The first stage of data presentation. Before entering numerical values into a database in Excel format or directly during data entry in the SPSS program for statistical processing, the researcher must check the obtained data for accuracy and completeness in order to identify possible errors. This process includes verifying missing information or limited responses and double-coded answers. Based on this verification, the researcher makes the necessary decisions for further data processing. Measurement scales in statistical observation and analysis. The type of variable used in statistical observation and analysis depend on the method of statistical measurement applied. That is the type of measurement scale. Different statistical scales are used depending on the nature of the measured variables and the objectives of the analysis. In the SPSS program, the measurement scale for each variable can be set as one of the following scale. It means quantitative for interval or ratio data, ordinal and nominal. Data preparation stages for statistical analysis. First, checking the accuracy and completeness of the data. Label each variable and the coding sheet in the tool or directly in the data entry program. Computer variable labels using the naming conventions adopted by the specific statistical software planned for use. Create a complete coding sheet. Enter the data using double checking or perform other quality control procedures. Clean raw data files before processing the information. Create the final evaluating scale. The first stage of data preparation before entering numerical values into the database in the Excel format or directly during data entry in the SPSS program, the researcher must verify the obtained data for accuracy and completeness in order to identify possible errors. This process involves checking for missing information, ambiguous or limited responses, and double-coded answers, followed by making the necessary decisions for further data processing. The second stage of data preparation. At the second stage of data preparation, the researcher must define each variable in a coding sheet, also known as a coding map, in the instrument or directly in the data entry program. When assigning variable names in the SPSS data entry software, the rules of this statistical package must be followed. For example, one of the rules states that variable names cannot contain spaces. The third stage of data preparation. At the third stage, the researcher determines the order in which variables will be entered into the database. All numerical data collected according to the developed format are entered into the database in a specific sequence. For statistical processing, the raw data must be presented in tabular form. Each row in the table corresponds to one observation unit, and each column corresponds to one indicator. All necessary information should be included in the table. Usually, each participant in the study is assigned a unique identification number. In the SPSS data editor, the label field is used to assign a variable label. A variable label is a descriptive name explaining the meaning of the variable. Value labels are especially useful when numeric codes are used to represent non-numeric categories. For instance, for the variable gender, numeric codes 1 and 2 can be assigned labels female and male respectively. This field is important because the specified value labels appear in all tables and graphs during statistical analysis. To process the collected data, the researcher must first create a control file or coding table which represents a list of variable labels. During the research process, it's often necessary to work not only with numerical data, but also with textual data. The SPSS program allows for statistical processing of data presented in a numeric equivalent. Therefore, a coding method is applied, a procedure that expresses one type of data through another type, so that all data are represented in numerical format. The correspondence between variable values and coding numbers is defined in a coding sheet, which establishes the link between the individual questionnaire items and the variables used for computer-based data processing. For example, the value female can correspond to the code 1, while male corresponds to 2. The fifth stage, entering numerical data. At the fifth stage, numerical values are entered either manually or automatically. There are many programs designed for data entry and storage on a computer, and most of them are quite similar in function. Most statistical packages allow data to be entered directly into the program. However, certain limitations exist. In particular, data cannot be easily transferred from one statistical package to another. A simple alternative is to store data in a spreadsheet format or in a database system where specific software tools are preferable for handling large datasets. Regardless of how the data were entered, at the sixth stage, the researcher performs data cleaning process to verify how accurately and correctly the data were transferred to the database. This stage ensures the reliability of the data and checks for missing information, duplicates, and whether the responses were properly coded. It also helps identify possible errors that may have occurred during data entry, since random mistakes can happen during this process. The seventh stage of preparing data for analysis involves reducing large amounts of information into general categories, summary scores, or individual numerical indicators. To summarize individual items, the researcher creates an index or scale and calculate descriptive statistics, which help reduce and combine individual responses and scores. This process is often referred to as data reduction. The SPSS program allows researchers to perform various statistical calculations on large datasets and to create complex graphical representations based on the results of the analysis. Thank you for your attention.